The ground is pale, a wide basin of gypsum and sun, where the wind moves as if still polishing the bones of an older world. White dunes roll under a hard sky. The lake that once spread here is gone. The animals that stepped through its shallows belong to a vanished age mammoths with curved tusks, giant ground sloths, camels, dire wolves, ancient horses, all leaving signatures in wet mud that no one expected would become an archive. But among those tracks, pressed into the same ancient surfaces, are shapes that change the story more deeply than any single stone point or broken bone. Human feet crossed this place when the last ice age still held much of North America in its grip. The footprints do not look dramatic at first. They're not golden treasure, walls, temples, tombs, or carved monuments. They're shallow impressions in ancient lakebed sediment, some so fragile that light and shadow must help reveal them. Yet they carry an unsettling power because they are not abstract. A footprint is a moment. It is weight, direction, balance, hesitation, speed. It is a body passing through a real landscape, not a theory moving across a map. At White Sands, what survives in the record suggests people walking along the edge of a Pleistocene lake, roughly 21,000 to 23,000 years ago, when the old Clovis-first timeline would once have placed the earliest widely accepted Americans thousands of years in the future. Before we go deeper, take a moment to like the video and subscribe, if this is the kind of history and mystery you enjoy. The story ahead is not simply about who arrived first. It is about how difficult it is to recognize the first traces of people when water rises, ice advances, shorelines disappear, and the oldest clues are often the easiest to doubt. The mystery begins with a strange imbalance. The Americas are enormous, stretching from Arctic tundra to tropical forest, from glacier margins to deserts, from salmon rivers to Andean highlands and Patagonian wind. If people reach these continents early, they did not enter an empty stage. They entered a world dense with life, danger, opportunity, and change. But the archaeological record does not preserve every campfire pathway, shoreline pause, or lost tool. It preserves accidents. It preserves what mud buries quickly, what caves shelter, what riverbanks do not destroy, what later erosion happens to expose. In a story this old, absence is not silence. It is often damage. For much of the 20th century, the beginning seemed cleaner. Clovis people, known for beautifully made fluted spear points, appeared across North America around 13,000 years ago. Their tools were distinctive, widespread, and hard to mistake, offering a sharp horizon, almost like a line drawn through deep time. A simple story formed people crossed from Siberia into Alaska, moved through an ice-free corridor when the glaciers allowed it, spread quickly south, and became the first Americans. But the ground kept refusing to stay simple. Sites older than Clovis began to gather at the edges of the accepted map. Chile, Idaho, Florida, Texas, Yukon, Mexico, New Mexico. Each place offered a different clue, and each clue came with its own burden of proof. A hearth had to be shown to be human-made, not wildfire. A broken bone had to be shown to be worked or butchered, not cracked by pressure, freezing, or animal activity. A stone had to be shown to be an artifact, not merely a geofact, a natural fragment pretending to be a tool. The older the claim, the heavier the doubt became. And no claim is heavier than the possibility that people were in the Americas perhaps approaching 30,000 years ago or more. That number, 30,000, does not sit comfortably. It pulls the story into a colder, stranger world. It demands explanations for movement during harsh climatic conditions, for people navigating barriers that were never static, for genetic evidence that must be reconciled with archaeology, and for long gaps where the record seems thin or missing. Scholars still debate how far back the strongest evidence can safely go. White Sands has become central because its footprints are direct human traces, and because later dating work has strengthened the argument for a last glacial maximum age. Yet even here, the science is careful. Seeds of an aquatic plant called Rupia serosa became part of the dating discussion. And because aquatic plants can sometimes carry complications from older carbon dissolved in water, researchers have had to test and refine the chronology. This is the slow discipline behind the drama, not one discovery ending the debate, but several lines of evidence forcing the question to remain open. The scene those footprints belong to is almost difficult to imagine from the modern desert. During the Ice Age, the Tularosa Basin held Lake Otero, a broad wetland system that expanded and shrank with climate. Around its margins, mud could hold a print just long enough for wind-blown sediment, mineral-rich water, or changing moisture to seal it away. The people walking there were moving through a living world of water, reeds, open ground, animal trails, and distant mountains. They may have been following resources along the lake edge, crossing between camps, tracking animals, or simply taking the easiest route across wet sediment that held the memory of every footfall. Some tracks are large, some small, suggesting groups rather than solitary wanderers. That quiet detail makes the deep past feel less like a migration arrow on a map, and more like a community moving through a day. There is a lesser-known strangeness in footprints that stone tools rarely preserve. Tools can travel, they can be dropped, traded, reused, carried far from where they were made. A footprint cannot. It belongs to one place and one moment, at White Sands. Ancient human tracks intersect with animal tracks, sometimes crossing surfaces also marked by mammoths or giant sloths. The meaning is simple, and deep humans shared that landscape with enormous creatures, while the ecological order of North America was still Pleistocene. They were not arriving after the Ice Age world had ended. They were inside it. And still, the evidence remains incomplete. Footprints tell us presence, not origin. They show that someone was there, but not exactly how their ancestors arrived, how long they had been in the continent, or whether they represented a pioneering population, a broader settlement, or one thread in a much more complicated movement. To reach White Sands by 23,000 years ago, people must have entered the Americas earlier still, unless they moved with astonishing speed through landscapes often blocked, flooded, or poorly suited to travel. That is where the mystery widens beyond New Mexico. It reaches back toward Beringia, the lost land between Siberia and Alaska. It reaches along drowned Pacific shorelines now hidden beneath the sea. It reaches into caves where stone fragments may or may not be tools, and into genomes where ancestry survives long after camps have vanished. So the first image is not a spear point in a museum drawer. It is not a triumphant arrival. It is a line of feet crossing damp ground beside an Ice Age lake. While glaciers dominate the north, and vanished animals move under a sky that no living person has seen. The people who made those prints do not explain themselves. They leave no names, no myths, no carved histories. They leave pressure in mud, held by chance through thousands of winters, waiting until modern eyes learn how to read it. And once those prints are seen, the old beginning of the Americas no longer feels like a doorway. It feels like a curtain, and behind it there is another room, darker, older, and not yet fully entered. For a long time, the story had a clean edge, and that edge was Clovis. Archaeology often prefers caution, but it also prefers patterns, and Clovis offered one of the most persuasive patterns ever found in American prehistory. Across wide parts of North America, researchers uncovered elegant stone points with a distinctive flute struck from the base, a channel removed with impressive skill so the point could be fitted into a shaft. These artifacts appeared in association with Pleistocene animals and late Ice Age landscapes, and they seemed to arrive suddenly, almost as if a people with a recognizable toolkit had stepped onto the continent and spread with extraordinary speed. For decades, this became the wall at the beginning of the American story. The wall was never only made of stone, it was made of confidence. Clovis sites had clear tools, datable contexts, and a broad geographic reach. They gave archaeologists something solid enough to build around. The model became familiar ancestors of Native Americans crossed Beringia from Northeast Asia, waited until ice sheets retreated, moved down through an interior corridor between the Great Laurentide and Cordilleran ice sheets, and then expanded across the continents around 13,000 years ago. On paper, it was elegant. On maps, it looked almost inevitable. It connected geology, climate, migration, and artifact style into a single sequence. And because earlier claims were often messy, ambiguous, or poorly dated, the Clovis-first model seemed not just plausible, but responsible. There is a reason older archaeological claims are treated with suspicion. Deep time is full of false signals. A cracked cobble can look like a tool if someone wants it badly enough to be one. Burned sediment can come from natural fire. Bones can fracture under pressure. Freeze-thaw cycles, trampling, carnivore activity, or simple collapse. Charcoal can move through layers. Water can reorder a site. Burrowing animals can mix yesterday with 10,000 years ago. Even careful excavation can be haunted by old mistakes if early field notes were thin or dating methods were not yet refined. The older a proposed site is, the more it must survive not only erosion and time, but human skepticism. Still, cracks began to appear. They did not appear all at once. They came as irritations at first, anomalies that could be explained away or placed in the category of interesting but unproven. Some sites suggested people might have been present before Clovis. Some seemed too far south too early. Some had artifacts that did not look Clovis at all, which made them harder to classify rather than easier to accept. This strange thing about a dominant model is that it shapes what researchers expect to find. If the first Americans are supposed to look like Clovis, then older people without Clovis tools become almost invisible. Their evidence has to argue not only for itself, but against the habit of a field. The quiet revolution did not come from one perfect discovery. It came from accumulation. Monteverde in Chile became one of the first major blows to the old wall because it lay far south in South America and showed evidence of human presence earlier than the classic Clovis horizon. The site was not a simple scatter of points. It included preserved organic remains, structures, plant materials, and traces of human activity in a wet environment that had sealed away unusual details. For many archaeologists, Monteverde showed that people must have reached the far end of the Americas before Clovis people appeared in the north. If that was true, Clovis could not be the beginning. It could only be one later expression of a larger human story. The acceptance of Monteverde was not immediate, and that matters. It became a lesson in how scientific consensus actually changes slowly, reluctantly, through repeated examination, through visits by critics, through arguments over sediment, context, dating, and interpretation. Even after broader acceptance formed around a pre-Clovis age for the site, debate did not vanish. In recent years, Monteverde has again become part of a dispute over chronology and interpretation, reminding everyone that even famous sites can return to the centre of controversy. The evidence remains incomplete, not because nothing is known, but because archaeological certainty is rarely permanent. It is always tied to methods, contexts, and new questions. Other sites added pressure from different directions. In Idaho, Cooper's Ferry provided evidence of human activity around 16,000 years ago, with stone tools that did not belong neatly to the classic Clovis pattern. Its location near the Salmon River made it important because it suggested early movement into the interior northwest, before the ice-free corridor was likely to have been an easy route for people traveling south from Alaska. In Florida, Page Ladson preserved evidence in a submerged sinkhole environment, where humans and Pleistocene animals overlapped in a landscape now changed beyond recognition. In Texas, the Deborah L. Friedkin site placed older stone tools beneath Clovis layers, a literal stratigraphic challenge to the old idea that Clovis came first. These sites did not all say the same thing. That is part of their importance. They were not copies of one culture spreading a single artifact style. They suggested variation, local adaptation, and perhaps multiple technological traditions before the famous fluted point became widespread. The old wall cracked because the evidence behind it had been too neat. Real human movement tends to be less neat. People explore, pause, return, split, adapt, and vanish from places. Some groups leave behind distinctive tools, others leave traces so plain they are difficult to recognize. A continent can be entered long before a recognizable archaeological signature becomes widespread. A lesser-known detail in the Clovis story is that its very brilliance may have distorted the timeline. Clovis points are beautiful and technically demanding, but their visibility may say as much about preservation and recognition as about first arrival. Archaeologists can identify them across great distances because they are so distinctive. Earlier tools may have been simpler, more expedient, more local, or made from materials that did not preserve well. A people who used bone, wood, fibre, or small flakes along a coast now underwater might leave almost nothing that survives the tests of modern archaeology. The most visible culture is not always the earliest culture. Sometimes it is merely the first one the ground makes easy to see. The fall of Clovis-first did not make the story easier. It made it more interesting and more difficult. Once Clovis was no longer the beginning, every older clue had to be placed into a larger landscape of possibilities. Were there people south of the ice sheets before the last glacial maximum reached its harshest phase? Did some populations wait in Beringia for thousands of years before moving farther? Did coastal groups travel along the Pacific Rim, using marine resources and kelp forests as a moving lifeline? Did inland routes open earlier in some places than others? No single explanation fully accounts for all the evidence, especially when archaeology, genetics, climate models, and sea level history do not always line up cleanly. What changes most is the feeling of the map. Instead of one doorway opening after the ice retreats, the Americas begin to look like a continent approached through shifting margins. Some paths are blocked by glaciers, then open, then change again. Shorelines rich in food are later swallowed by rising seas. Interior basins become wetlands, then deserts. Rivers cut away old camps. Caves preserve fragments that may be real traces or deceptive stones. The first Americans are no longer a single wave arriving with one signature tool. They are a problem of timing, movement, survival, and recognition. Clovis remains important. It was not a mistake, not a myth, not a discarded chapter. It represents a real and remarkable archaeological culture, one that spread widely and left a powerful mark near the end of the Ice Age. But it no longer stands alone at the threshold. Behind it are older footprints, older camps, older stone technologies, older debates. The wall has not vanished completely. Parts of it still shape the questions, but there are openings now, and through those openings the story becomes colder, wider, and far less certain than it once appeared. To understand why the first American story is so difficult to pin down, the continent itself has to be seen as it was before it became familiar. Around 30,000 years ago, North America is not the map that modern eyes know. Much of the north is locked beneath enormous ice sheets or caught in the unstable weather around them. Sea levels are lower because so much of the world's water is trapped as ice, pulling coastlines outward and exposing lands that are now drowned. Rivers follow different courses. Lakes swell in basins that are dry today. Deserts are not always deserts. Grasslands spread where forests may later grow. The world is colder, but not uniformly dead. It is alive in a hard, restless way. The Great Laurentide ice sheet dominates the northeast and centre of the continent, a mass of ice so large that it changes climate, drainage, and even the weight pressing down on the crust of the earth. To the west, the Cordilleran ice sheet spreads over mountains and coastal ranges. Between and around these frozen systems, landscapes shift constantly. Glaciers advance, pause, retreat, surge again. Meltwater cuts channels and feeds lakes. Dust blows from exposed floodplains. Entire ecosystems move south, east, west, or upward and downward in elevation as temperature and moisture change. A traveller entering this continent does not face one simple barrier, but a living maze of ice, water, wind, animals, and season. Far south of the ice, the land is not empty wilderness in the romantic sense. It is crowded with unfamiliar giants. Mammoths graze on open steppe and parkland. Mastodons browse in wetter wooded environments. Ancient horses move in herds. Camels, native to North America long before they vanish from it, cross dry country. Giant ground sloths leave heavy tracks. Saber-toothed cats, American lions, short-faced bears, dire wolves, and other predators occupy the dangerous edges of this world. Even animals that seem ordinary by name are different in scale, range, or abundance. The continent is not waiting for people. It is already a fully inhabited world. This matters because early humans entering the Americas are not simply moving across geography. They are entering relationships. Every new valley has plants that must be learned, animals that must be watched, weather that must be read, stone sources that must be found, water that must be trusted or avoided, and seasonal rhythms that may punish mistakes. What survives in the record suggests human beings were astonishingly adaptable by this time. But adaptation is not magic. It requires memory, cooperation, observation, and time. A group arriving in a new land must learn where animals migrate, when roots or seeds are available, where shelter is possible, where floods come, and which roots become traps under snow, heat, mud, or water. The Ice Age Americas also hold environments that no longer exist in the same form. One of the most important is the Mammoth Steppe, a cold, dry, productive grassland ecosystem stretching across parts of northern Eurasia and Beringia and influencing parts of North America. It is not a frozen desert. It can support enormous herbivores because grasses, sedges, and herbs grow across broad open spaces. In places, The air is cold, but the land is biologically rich. This is one of the surprises of the Pleistocene. Harsh does not always mean barren. A landscape can be dangerous and generous at the same time. Beringia, still ahead in the story, is part of this wider Ice Age logic. Because sea levels are lower, the land between Siberia and Alaska is exposed, creating not merely a bridge but a broad region with its own environments. But once beyond that northern world, movement deeper into the Americas becomes more complicated. Ice blocks many direct paths. Coastal margins may offer travel and food, but many of those shorelines now lie underwater. Inland routes may open and close unevenly. The continent is less like a hallway and more like a series of changing doors, some visible only for a few thousand years, some leading into rich country, some ending at ice, mountain, desert, or flooded basin. Around 30,000 years ago, the last glacial maximum has not yet reached its peak, but the world is moving toward it. By roughly 26,000 to 19,000 years ago, ice volumes grow to their great extent. This timing is one reason the 30,000-year question is so charged. If people are present in the Americas before or during that severe interval, then they are not merely slipping through a convenient post-glacial opening. They are surviving in a world of climatic pressure. They may be using refugia, corridors, coasts, river systems, or ecological pockets that later disappear from view. Scholars still debate whether the archaeological evidence can support such an early presence widely. But the environmental challenge is clear. Early entry is not just a date. It is a survival problem. South of the ice sheets, different regions offer different possibilities. The American Southwest includes lakes, wetlands, open basins, and animal-rich margins that later dry into desert landscapes. White Sands belongs to this kind of changed world, where a vanished lake bed holds prints from animals and people long after the water is gone. The Great Plains are not simply grasslands as later known. They are shifting mosaics influenced by cooler conditions, changing rainfall, and roaming herds. The Pacific coast, where not buried by ice, may include productive marine zones, shellfish, fish, sea mammals, birds, and edible seaweeds. The Atlantic and Gulf margins also look different, with broad exposed coastal plains in places that now lie beneath shallow seas. In South America, the range of environments becomes even more extreme. Tropical forests, high Andes, dry coasts, grasslands, wetlands, and cold southern regions all form part of the long human puzzle. If people reached far southern South America before Clovis appears in the north, they must have moved through or around a staggering diversity of landscapes. Monteverde became so important partly because it sits in that wider implication. A human presence in southern Chile by around 14,500 years ago, even amid later debate and renewed scrutiny, suggests that the peopling process began earlier than the old model allowed. A continent cannot be crossed instantly, especially not by people learning each environment as they go. There is another detail that makes the Ice Age world difficult to reconstruct. The best routes for people may have been the worst routes for preservation. River valleys attract camps, but rivers destroy and bury. Lake margins preserve footprints, but only under rare conditions. Coasts offer food and movement, but rising seas drown them. Caves shelter evidence, but cave geology can fracture rock, move sediment, and create arguments over what is human and what is natural. Open-air camps may vanish under soil, agriculture, erosion, or urban development. The first Americans may have favoured exactly the places that modern archaeology struggles hardest to reach. So the continent itself becomes a character in the mystery. It hides as much as it reveals. It invites movement along some edges and blocks it along others. It preserves footprints in one basin and erases entire shorelines elsewhere. It offers rich animal worlds while demanding knowledge that newcomers must build quickly or bring from related northern environments. No single explanation fully accounts for this shifting stage, because the stage never stops shifting. By the time Clovis points appear in the archaeological record, the Americas have already passed through millennia of climatic change, ecological tension, and possible human movement. The question is not only who arrived first, it is what kind of world allowed their traces to survive at all. At the northern edge of the story, the map opens into a place that no longer exists. Today, Siberia and Alaska are separated by the Bering Strait, a cold marine passage where continents seem to face one another across water. But during parts of the Ice Age, when sea levels fall far below their modern position, that water withdraws and exposes a vast landmass. It is often called the Bering Land Bridge, but that phrase makes it sound narrow, temporary, and simple, like a path one crosses on the way to somewhere more important. Beringia was not merely a bridge, it was a world. At its greatest extent, Beringia included parts of northeast Siberia, Alaska, Yukon, and the exposed land between them. It stretched across an immense region of lowlands, river valleys, dry tundra, grasslands, wetlands, and cold steppe. The land that is now under the Bering and Chukchi seas may have been wide enough to hold generations of human life, not just a passing migration. This changes the emotional scale of the peopling story. The first Americans may not have rushed from Asia into an empty continent. Their ancestors may have lived for a long time in a northern world that has mostly disappeared beneath shallow ocean. Beringia existed because ice locked away seawater, but paradoxically, much of Beringia itself was not buried beneath giant ice sheets. It was cold, certainly, and often severe, yet it was also relatively dry. The great glaciers formed where moisture and mountains allowed them to grow. In parts of Beringia, low precipitation helped keep the land exposed. The result was a strange refuge at the edge of ice, a region where plants and animals could persist, while glaciers dominated areas to the east and south. Pollen, plant remains, insects, and animal fossils suggest a landscape of grasses, sedges, herbs, dwarf shrubs, and seasonal wetlands. A place less like a frozen wasteland than a tough, open, productive country. For people adapted to northern Eurasian environments, Beringia may have felt unfamiliar but not unimaginable. It had stone, bone, wood in some refugial areas, hides, animal fat, fresh water, and seasonal movement patterns that could be learned. Herd animals moved through open ground, birds gathered in wetlands. Fish and other aquatic resources may have mattered where rivers and coasts allowed them. The environment demanded skill, but it was not empty of resources. What survives in the record suggests that late Pleistocene humans across Eurasia already understood how to live in cold climates through clothing, shelter, fire, planning, and social cooperation. Entering Beringia would have required those abilities at high level. Still, the phrase land bridge hides danger. A bridge implies direction. Beringia may have involved waiting. One influential idea, often called the Beringian standstill or Beringian incubation model, proposes that ancestral Native American populations may have spent thousands of years isolated or semi-isolated in Beringia before expanding into the rest of the Americas. This is not a single fixed event that can be pinned neatly to one camp or one valley. It comes partly from genetic patterns, partly from climatic logic, and partly from the problem of timing. If people were separated from their Asian relatives before their descendants spread through the Americas, then Beringia becomes more than a corridor. It becomes a homeland in between worlds. The evidence remains incomplete because much of the central region where this might have happened is now underwater. If people camped along rivers crossing the exposed plain, if they followed animals across lowlands now drowned, if they left hearths, tools, shelters, or burials there, most of those traces lie beyond ordinary excavation. Archaeology is forced to work around the edges, Siberia on one side, Alaska and Yukon on the other, and the submerged middle largely missing. This creates one of the great frustrations of the first Americans' puzzle. A place that may have been central to the story is physically absent from the modern landscape. Yet the surrounding clues matter. In Northeast Asia, archaeological sites show humans living in cold regions before the final peopling of the Americas. In Alaska and Yukon, early evidence is more fragmentary and often debated, but it keeps Beringia in view as a plausible northern stage. Bluefish Caves in Yukon, for example, has been argued to contain evidence of human activity around 24,000 years ago, based partly on modified bones. The claim remains treated with caution by many scholars, but it is important because it places the debate inside Beringia during the last glacial maximum itself. It does not solve the story, but it sharpens the question: were people already waiting in the north while ice still blocked easy movement south? The problem of movement out of Beringia is just as complex as movement into it. To the southeast, glaciers closed or narrowed possible inland routes. The ice-free corridor between the Laurentide and Cordilleran ice sheets, once central to the Clovis-first model, may not have been biologically useful early enough for the oldest pre-Clovis sites. A corridor on a map is not the same as a corridor people can live through. It needs plants, animals, water, fuel, and seasonal viability. If the land is newly deglaciated but ecologically barren or unstable, it may be open in a geological sense and still closed in a human sense. This is why Beringia connects naturally to the coast. If interior routes were blocked or poor at key times, people may have moved along the Pacific margin, using coastal resources and travelling by foot, boat, or a mixture of both. But the Beringian coast itself has changed. Lower sea levels exposed shorelines that later vanished. Glaciers covered some coastal areas while leaving others open at different times. Kelp forests, shellfish beds, fish runs, bird colonies, and marine mammals could have offered a rich pathway, but much of that ancient pathway is now drowned. The route that may have made movement possible is also the route most efficiently erased. There is a lesser-known subtlety in all this: early migrants did not need to think of themselves as migrating to a new continent. People moving through Beringia may have followed animals, seasons, coastlines, marriages, stone sources, or familiar horizons. A generation might shift a little east, another a little south, another return north, another split along a river system. Only thousands of years later does the movement look like a grand continental migration. From the ground. It may have been a series of decisions made under weather, hunger, memory, and opportunity. This makes the first American story less like a single crossing and more like a long northern pause followed by openings. Beringia gathers together climate, genetics, archaeology, sea level, and imagination, but not imagination in the careless sense. It asks modern researchers to reconstruct a vanished country from fragments around its edges. Scholars still debate how long people stayed there, how many groups were involved, and whether movement into the Americas happened mainly before, during, or after the harshest phases of the last glacial maximum. No single explanation fully accounts for all the evidence. What can be said is that the old bridge is gone, and with it perhaps many of the first pages of the American story. The sea now covers lowlands where smoke may once have risen from camps. Currents move over places where animals crossed and people watched the weather. The map has healed over the opening, leaving only Alaska, Siberia, genetics, scattered bones, stone, and argument. To follow the mystery farther, the story must move along the margins that survived least well the ancient coastlines, now drowned, where some of the earliest travellers may have found their way south. The coast is where the story becomes both more plausible and more difficult to prove. If people stood in Beringia and looked south, the interior of the continent was often blocked, narrowed, or made uncertain by ice. But the edge of the Pacific may have offered another kind of road. Not a road of dry earth alone, but a shifting ribbon of beaches, headlands, estuaries, islands, kelp forests, river mouths, and sheltered coves. It would not have looked like a highway in the modern sense. It would have been broken, seasonal, dangerous in storms, rich in some places and poor in others. Yet for people who understood shorelines, tides, boats, fish, shellfish, birds, and sea mammals, it may have been one of the most important passages into the Americas. This idea is often described through the image of a kelp highway, though the phrase can make it sound too smooth. Kelp forests are not roads, and ancient people were not simply drifting south on a single ecological conveyor belt, but along parts of the North Pacific Rim. Kelp ecosystems can support dense webs of live fish, shellfish, sea otters, seals, birds, and other resources that gather near rocky shores and underwater forests. If similar systems existed along glacially open stretches of coast, they may have offered predictable food in a world where inland routes were uncertain. The coast could have provided water, fuel from driftwood in some areas, stone from exposed outcrops, and a natural line of movement that did not require crossing the heart of the ice sheets. There is nothing inherently unlikely about ancient people using coasts. Human groups had already reached islands and coastal zones elsewhere in the world long before the final peopling of the Americas. By the late Pleistocene, people were capable of planning, navigating, using complex tools, and exploiting marine or nearshore resources where conditions allowed. But the archaeological challenge is brutal. The coast that matters most is not the coast visible today. During the last ice age, sea level stood far lower, exposing broad continental shelves. Camps that might once have sat beside coves or river mouths could now lie beneath tens or even more than 100 meters of water. The very route that may explain early movement is the route that rising seas have hidden. This is one of the quiet tragedies of the first Americans' puzzle. A group moving along the coast may have left shell middens, hearths, stone flakes, food remains, wooden tools, fibre objects, boats, or temporary shelters, and almost all of it could now be submerged, scattered, buried in marine sediment, or destroyed by waves. The ocean does not merely cover evidence, it grinds it, moves it, sorts it, dissolves it, and hides it beneath layers that are expensive and difficult to investigate. On land, archaeology already depends on luck. Underwater, that luck becomes narrower still. The Pacific coast was also not a single open lane. Glaciers reached the sea in some places. Ice margins shifted, sea ice, storms, steep cliffs, and limited landing places could have created barriers. In other places, refugia may have remained open, with plants and animals surviving along coastal pockets even during cold intervals. Recent studies of the North Pacific coast have focused closely on when these ecological openings existed, because a coastline without food is not a migration route in any human sense. To travel, people need not only space but a chain of viable places somewhere to land, gather, rest, make tools, find fresh water, and move again. A route can exist geographically and still fail biologically. The surprising detail is that some coastal regions may have become habitable earlier than the old ice-free corridor inland. This does not prove that people used them first, but it changes the hierarchy of possibilities. For a long time, the interior corridor seemed like the obvious gate into the Americas because it appeared on a map as a gap between ice sheets. But once researchers began asking when that corridor contained enough plants and animals to support human travel, the answer became less convenient. If the corridor was too late or too poor for the earliest pre-Clovis occupations, then the coast becomes harder to ignore, even without abundant archaeological sites from the drowned shoreline. The coastal idea also helps explain the strange geography of some early evidence. If people moved down the Pacific margin, they could have reached regions far south before leaving many visible traces inland. From there, groups might have moved up rivers, into basins, across mountains, and eventually into places like the interior northwest, the southwest, or farther south into Central and South America. This does not require a single rapid race from Alaska to Chile. It allows for pulses, pauses, expansions, returns, and local adaptation. It also explains why a site far from the northern entry point can appear unexpectedly early. The shoreline may have been the hidden spine of movement, while the inland record preserves only scattered branches. Yet caution is essential. Scholars still debate the timing, scale, and nature of any coastal migration. Some versions of the idea are well grounded in ecology and sea level history. Others become too sweeping, using the drowned coast as an answer for every missing piece. The fact that evidence may be underwater does not allow every speculation to become true. It only means that the absence of coastal sites cannot be treated as decisive proof against coastal movement. This is an uncomfortable balance. The coast is plausible because it fits several constraints. It remains difficult because so much of the strongest evidence may be beyond reach. Underwater archaeology has begun to change what researchers consider possible. Ancient shorelines can sometimes be mapped using bathymetry, sediment cores, sonar, and models of sea level rise, paleo-river channels, former lagoons, drowned terraces, and submerged caves can guide searches. In some parts of the world, underwater prehistoric sites have been found where people once lived on land before the sea rose. Along the Pacific coast of the Americas, the work is challenging because tectonics, glaciation, erosion, and deep water complicate the picture. But the search itself matters. It turns the drowned coast from an excuse into a testable landscape. There is also the question of boats, which leave almost no trace in deep time unless preservation is extraordinary. A coastal route does not always require large seagoing vessels. Short crossings, near-shore travel, skin boats, rafts, dugouts in later contexts, or other perishable watercraft could transform movement along broken coastlines. But because wood, hide, cordage, and fibre rarely survive from such early periods, researchers must infer cautiously from indirect evidence. A people could have used watercraft for generations and leave no boat behind. The record may preserve stone flakes from a landing place while losing the technology that made the landing possible. The coast, then, is a corridor made of missing evidence. It is not empty, it is submerged. It does not solve the 30,000-year problem by itself, but it gives the problem room to breathe. If people were present in the Americas well before Clovis, especially before the interior corridor was fully useful, then some movement along Pacific margins becomes a serious possibility. If white sands places humans deep in North America during the last glacial maximum, then their ancestors had to arrive by a route compatible with ice, ecology, and time. The coast is one of the few candidates that can carry that burden, though not without questions. What survives in the record is uneven footprints in a vanished lake bed, tools in river terraces, disputed stones in caves, bones marked in ways that may or may not be human, genetic signals in living and ancient peoples, and coastlines lost beneath the sea. The Pacific margin may hold some of the earliest chapters, but it keeps them under water, under sand, under kelp and current. The first Americans may have moved through places that are now blue on the map, places modern viewers imagine as ocean but that were once walking ground, camping ground, hunting ground, gathering ground, and memory. To follow the story from that drowned edge, the evidence must turn inland again, into caves, bones, hearths, and stone, where each clue has to survive the hardest question archaeology can ask: is this truly human? Once the coast disappears beneath the sea, the surviving story turns back to harder ground caves, river terraces, buried floodplains, sinkholes, rock shelters, and open camps sealed under layers of sediment. These places do not speak with equal clarity. Some preserve human activity almost tenderly, holding flakes, hearths, bones, plant remains, and living surfaces in positions that can still be read. Others preserve confusion. Stones fall from ceilings. Water moves objects through cracks. Animals drag bones into dark chambers. Roots, burrows, and freeze-thaw cycles disturb layers that once seemed orderly. The deeper archaeology goes, the more it has to separate human action from the endless machinery of geology. This is why a pre-Clovis site is never accepted simply because it is old. It must prove that the material is real, that it is in place, that it has been dated correctly, and that the traces were made by people rather than natural processes. A stone tool is convincing when it shows patterns of deliberate flaking, repeated reduction, edge preparation, use wear, and a context that makes sense with other evidence. A butchered bone is persuasive when cut marks have the right shape, placement, microscopic structure, and association with human activity. A hearth must show more than burned earth. It should show controlled fire, charcoal, heat-altered stone, food remains, or a pattern that is difficult to explain as wildfire. Every clue must survive a courtroom where time itself is the opposing witness. Caves are especially powerful and especially dangerous. They protect deposits from weather, but they also create their own tricks. Rooffall can shatter stone into sharp fragments. Sediments can slump. Rodents and carnivores can mix bones. Water can carry small objects downward or sideways. Humans may return to the same cave over thousands of years, leaving occupations stacked so close together that later activity presses into earlier layers. A cave can preserve evidence beautifully, but it can also produce artifacts that only seem human until studied more closely. This is why Chiquihuite Cave in Mexico has become such a charged name in the first Americans' puzzle. Its reported stone assemblage and early dates raise the possibility of human presence around 33,000 to 31,000 years ago, a claim with enormous consequences. But critics have argued that some of the supposed artifacts may be geofacts. natural fragments created by rockfall or sediment movement rather than deliberate tool-making. The debate matters because the site sits near the heart of the 30,000-year question if Chiquihuite is truly archaeological. The story opens far earlier. If it is mostly natural stone breakage, caution pulls the timeline back. The same tension appears in bones. At Bluefish Caves in Yukon, modified animal bones have been used to argue for a human presence in Beringia around 24,000 years ago. The location is important because it fits the idea that people may have been living in the far north during the last glacial maximum, perhaps long before a broad movement south became visible. But bones are not simple witnesses. A mark can be made by a stone tool, a carnivore tooth, trampling, sediment pressure, or later damage. The argument depends on microscopic details, on which bones were marked, where the marks occur, how they compare to known butchery, and whether the dates truly connect to human action. Scholars still debate how much weight bluefish should carry, but its importance lies in the possibility it raises before people appear clearly across the lower continents. They may already be leaving faint traces in the northern threshold. Open-air sites face a different kind of exposure. They are vulnerable to erosion, river cutting, soil development, later disturbance, and human land use. Yet when preserved well, they can be extraordinarily revealing. Cooper's Ferry in Idaho is one of the key examples. Its buried deposits, stone tools, and carefully studied dates place people in the interior northwest around 16,000 years ago, earlier than Clovis, and in a location that complicates the old inland corridor model. The site does not simply push a date backward. It suggests that people with a non-Clovis technology were already using river landscapes in the Pacific Northwest interior, perhaps connected to movements that began along the coast or through earlier routes still poorly understood. The artifacts include forms that have drawn comparisons with Northeast Asian technologies, though such comparisons must be handled carefully. Similar shapes do not automatically prove direct cultural descent. Still, the pattern is intriguing because it hints that the earliest American tool traditions may have been diverse from the beginning. In Texas, the Deborah Friedkin site offers another kind of challenge older tools beneath Clovis layers. Stratigraphy has a quiet drama of its own. When one occupation lies below another in an undisturbed sequence, the ground itself becomes a timeline. At Friedkin, stone artifacts below the Clovis horizon suggest earlier human activity between roughly 13,500 and 15,500 years ago. These are not the grandest ages in the debate, but they are crucial because they show that Clovis did not appear out of nowhere as the first human expression in the region. It emerged after, beside, or from older technological traditions already present on the continent. That is a more complicated story, but it is also a more human one. Florida's Page Ladson site adds water back into the archive. Located in a submerged sinkhole system, it preserves evidence of people and Pleistocene animals in a landscape very different from the modern one. The site has yielded stone tools and mastodon remains in context dated to roughly 14,550 years ago. Underwater archaeology here does not mean oceanic coastline but a drowned inland setting, a place where changing water levels helped hide and protect evidence. The surprising detail is that such sites remind researchers how many early landscapes are not merely buried under soil, but submerged in rivers, sinkholes, lakes, and continental shelves. Some of the best evidence may lie where excavation requires diving as much as digging. Farther north, in Alaska's Tanana Valley, late Ice Age sites continue to add texture to the story of movement and adaptation. Finds of stone tools and mammoth ivory objects from places such as the Holzman site belong later than the most extreme pre-Clovis claims. But they matter because they show how people used northern landscapes near the threshold between Beringia and the rest of North America. Ivory tools are a reminder that stone was never the whole technology. Bone, antler, ivory, wood, hide, sinew, and fibre may have formed much of the actual toolkit, while stone survives because it is stubborn. Archaeology often mistakes durability for importance. The things that rot away may have mattered just as much as the things found in museum trays. Across these sites, the mystery is not only whether people were present, but how to recognize them before their traces become obvious. A Clovis point announces itself. A small flake from an older camp may whisper. A hearth stain may fade into sediment. A cut mark may require magnification. A footprint may appear only under the right moisture and light. No single clue explains the whole story, and no single explanation fully accounts for the unevenness of the evidence. What survives in the record suggests a continent entered, explored, and inhabited before the classic Clovis horizon. But the depth of that earlier presence remains contested. The oldest chapters are therefore built from fragments, and fragments resist certainty. Caves ask whether stones are tools or accidents. Bones ask whether marks are butchery or damage. River terraces ask whether layers stayed sealed. Sinkholes ask what lies below dark water. Each site becomes a negotiation between possibility and proof. Together, they create a strange pattern, not a clear road of evidence, but a constellation. Some stars shine bright. Others flicker at the edge of visibility. The next and brightest of these traces is not a blade, a bone, or a hearth, but something more immediate: human feet crossing wet ground in New Mexico, leaving behind a record so direct that it feels almost too fragile to have survived. At White Sands, the evidence does not begin as an object picked up by a hand. It begins as the shape of a handless thing, a foot pressing down into mud, then lifting away. The person moves on. The lake wind crosses the surface. The mud dries, softens, floods, hardens, and disappears beneath new sediment. Thousands of years pass. The step becomes a ghost under the basin floor, visible only when erosion, moisture, and light briefly agree to reveal it. This is why the White Sands footprints carry such force. They are not tools that could have been moved from one layer to another. They are not stones that might be natural. They are human movement fixed to an ancient surface. The landscape that holds them was once part of Lake Otero, a vanished Ice Age lake in what is now New Mexico. Today, the place is famous for bright gypsum dunes, but in the late Pleistocene it included wetlands, muddy margins, shallow water, and open ground where animals and people crossed the same basin. Mammoths left enormous rounded tracks. Giant ground sloths dragged heavy bodies through the wet surface. Ancient camels and dire wolves passed through. Into this crowded archive came human feet, some moving alone, some in repeated pathways, some forming trackways that suggest ordinary travel rather than ceremonial mystery. That ordinariness is what makes them haunting. The prints feel like a day preserved accidentally. Their age is the reason they matter so deeply. Dating work has placed many of the tracks around 21,000 to 23,000 years ago, during the last glacial maximum, when old models once made human presence deep inside North America very difficult to explain. The chronology has been debated carefully because the first dates relied in part on seeds from an aquatic plant, Rupia serosa. Aquatic plants can sometimes absorb older carbon from water, which can make them appear older than they truly are. That complication did not erase the site, but it forced the science to become more demanding. later research added and tested additional lines of evidence, strengthening the case that the tracks really do belong to a far older human presence than Clovis. The evidence remains incomplete, but it is no longer easy to dismiss White Sands as a chronological accident. Footprints also preserve human presence in a way artifacts rarely can. A stone point tells us about technology, a footprint tells us about bodies. It records stride, direction, pressure, speed, and sometimes the texture of the ground underfoot. Some prints appear elongated because feet slipped in soft mud. Some are clearer at the heel or toe depending on how the walker placed weight. Some vanish at the surface but can be detected as buried pressure features below, because the sediment beneath the foot was compressed differently from the sediment around it. This is a lesser-known detail of track archaeology. A footprint may survive even when the visible hollow is gone. The body changes the ground below the surface, and that hidden deformation can remain after the original impression fades. At White Sands, the human prints are not isolated curiosities. They belong to a broader trackscape, a preserved world of movement. The basin does not show people standing outside the Pleistocene ecosystem, watching it from a safe distance. It places them inside the same living terrain as the great animals. Tracks cross and overlap in ways that show the lake margin was used repeatedly. In some places, human footprints pass near or through animal trackways, not as dramatic scenes of confrontation, but as evidence of shared space. The people here understood a world in which enormous animals were part of the horizon, part of the daily calculation of movement, food, danger, and opportunity. Some of the human tracks are small, and this has led researchers to consider that younger individuals were among the people moving across the lake margin. The important point is not to turn that into a sentimental scene, but to recognize what it implies about community. These were not necessarily lone scouts testing an unknown continent. A range of foot sizes suggests ordinary social life moving through a landscape, groups traveling, gathering, crossing wet ground, returning along familiar paths. In deep prehistory, the presence of different ages can be one of the quietest signs that people were not merely exploring, but living. The dating of White Sands creates a pressure wave through every other part of the first American story. If people were in New Mexico around 23,000 years ago, they must have reached the Americas before that. They had to pass through, around, or along the great barriers of ice and sea. Their ancestors had to survive somewhere north or west of this basin, perhaps in Beringia, perhaps along a coast now submerged, perhaps through routes not yet visible in the archaeological record. A footprint in New Mexico becomes a question aimed at Alaska, Siberia, the Pacific Shelf, and every missing shoreline between. The site also changes how migration speed is imagined. Under the old Clovis-first model, rapid expansion after the ice-free corridor opened seemed possible because the timeline was compressed. But White Sands belongs to a time when the corridor explanation is far less comfortable. The people who made these prints may represent descendants of groups already established south of the ice sheets. That possibility turns the old arrival story inside out. Instead of asking how people arrived just before Clovis, researchers must ask how long earlier populations could have been present without leaving abundant, unmistakable sites. Scholars still debate the answer, but the question itself has shifted. There is a strange humility in footprints. They show presence without revealing language, belief, clothing, shelter, names, or ancestry. They do not tell whether the walkers came from a small local group, a larger regional population, or a lineage that later left little genetic trace. They do not explain whether these people contributed directly to later Native American populations or belong to movements that were absorbed, replaced, or simply remain invisible. DNA can speak to ancestry at a broad scale, but footprints speak only to the moment. They say someone was here. In a mystery crowded by models and dates, that directness is rare. And yet even direct evidence must be held carefully. White Sands is powerful, not because it answers every question, but because it resists the old limits. It does not prove a 30,000-year occupation of the Americas. It does not make every controversial site correct. It does not turn disputed stones into tools by association. What it does is push the securely argued human presence in North America into the last glacial maximum and force the older problem to be taken seriously. If people were walking beside Lake Otero 21,000 to 23,000 years ago, then the story before Clovis is not a fringe shadow at the edge of archaeology. It is a real chapter, even if many pages are missing. The most unsettling thing is how fragile the evidence is. A footprint can be destroyed by a storm, a vehicle, a careless step, or simple exposure. Its survival depends on sediment chemistry, burial, erosion, and discovery at just the right time. For thousands of years, the tracks slept beneath the basin, holding the pressure of vanished feet while the lake dried and the world changed around them. Now they stand as one of the clearest signs that the American story began earlier than once believed, not with a monument, not with a city, not with a named people, but with a line of steps across wet ground, fading even as they reveal a deeper past. Far from the white dunes of New Mexico, another landscape once changed the beginning of American history in a quieter way. It was not a desert basin under a hard sky, but a wet wooded place in southern Chile, where waterlogged ground held traces that should have vanished. Monteverde sits near a creek in a cool, damp region, far south of the old North American entry point imagined by the Clovis-first model. That distance is what made it so disruptive. If people were living in southern Chile around 14,500 years ago, then they could not have just entered North America around the classic Clovis horizon. They had already crossed continents, adapted to new environments, and reached almost the far end of the inhabited Americas before the old story said the story had truly begun. Monteverde did not overturn the timeline with one spectacular object. It did so through an accumulation of ordinary things preserved under extraordinary conditions. Wet ground can be destructive, but it can also protect organic material by sealing it away from oxygen. At Monteverde, researchers reported remains of wooden structures, plant materials, possible hearths, stone tools, worked materials, and traces of activity that suggested a human occupation unlike the familiar Clovis hunting sites of North America. The site felt domestic, practical, lived in. It did not present itself as a field of elegant spear points. It looked more like a place where people stopped, built, gathered, prepared, repaired, ate, organized space, and moved on. That difference mattered. Clovis had trained many eyes to expect early Americans to appear through fluted points and big game associations. Monteverde showed another face of early life, not only hunters crossing open plains, but people using wet forest edges, plants, wood, hide, stone, and local resources in a way that was less visually iconic but perhaps more representative of actual survival. What survives in the record suggests that early Americans were not bound to one ecological style. They could live in river valleys, lake margins, coastlines, forested environments, and open lands. The first chapters of the American story were never likely to be written in one kind of stone tool alone. One of the most surprising aspects of Monteverde was the range of plants connected to the site. Some plant remains appeared to come from different ecological zones, including coastal environments, which raised the possibility that the people there were not isolated in a tiny forest camp but were connected to a wider landscape of movement and gathering. Seaweed and other marine-linked resources became part of the discussion, suggesting that coastal knowledge may have mattered even far from the most obvious shoreline. This detail quietly strengthened the idea that the Pacific coast could have served as a major route or resource corridor. If people in southern Chile were using materials from diverse environments, then their world was not narrow. It was mapped through experience. Monteverde's importance was not accepted instantly. For years, it stood in the uncomfortable position of being too early, too far south, and too different from what many expected. The site had to endure inspection, criticism, and repeated debate. Its sediments, dates, artifacts, and interpretation were examined with unusual intensity because the consequences were enormous. Accepting Monteverde meant accepting that Clovis was not first. It meant the peopling of the Americas had begun earlier, perhaps by a coastal route, perhaps through movements still mostly missing from the record. It meant the old wall had a breach far to the south. The eventual shift around Monteverde became one of the great examples of archaeology changing under pressure from evidence. The old model did not vanish in a single dramatic collapse. It weakened as researchers recognized that a site in Chile could not be comfortably forced into the Clovis-first frame. A people living there around 14,500 years ago implied earlier movement through North America, Central America, and into South America. Even a rapid migration would need time. Landscapes had to be learned. Rivers and mountain ranges had to be crossed. Food sources had to be found. Social groups had to survive season after season. Monteverde turned distance into an argument, but the story has not remained settled in a simple way. Recent debate has brought Monteverde back into scrutiny, with new arguments challenging aspects of the site's dating and interpretation. A 2026 study questioned whether some of the archaeological surfaces might be younger than long believed, reigniting a dispute around one of the most famous pre-Clovis sites in the Americas. The response from many specialists was sharp, with critics arguing that the revision overreached or misunderstood key parts of the evidence. This does not mean Monteverde suddenly becomes meaningless, nor does it mean every older interpretation must stand unchanged. It means something more honest and more revealing. Even foundational sites remain active ground in science. That is one of the themes running through the entire First Americans puzzle. A site can be important and still debated. A discovery can change a field and still be re-examined decades later. Archaeology does not preserve certainty in amber. It works through sediment, statistics, field notes, old samples, new methods, and human disagreement. Monteverde's power lies partly in the fact that it forced a generation of researchers to look beyond Clovis, and partly in the fact that it still demands careful handling. Scholars still debate details of its chronology, but the broader lesson it helped establish remains difficult to erase. The earliest American story is older, wider, and more varied than the old model allowed. The southern location also raises a deeper question about visibility. If people reached Monteverde early, where are all the sites that should lie along the route? Some may exist and remain undiscovered. Some may have been destroyed by rivers, glaciers, volcanism, erosion, or later human occupation. Many coastal sites, if the Pacific route played a role, may now be underwater. Others may not look dramatic enough to be recognized at first. A simple camp, a scattering of flakes, a hearth stain, a few plant remains, a worn surface of occupation, these can be easy to miss, especially when the people who made them did not leave behind a familiar, continent-wide tool style. Monteverde also reminds us that the first Americans were not merely crossing land. They were transforming unfamiliar places into known places. A wet forest in southern Chile is not the same world as Beringian steppe, New Mexican lake margins, or Idaho river terraces. To live there, people needed knowledge of plants, shelter, water, fuel, animals, weather, and movement through damp terrain. They needed to understand what could be eaten, what could be carried, what could be shaped, and what seasons brought to the creek and surrounding country. No single explanation fully accounts for how quickly such knowledge spread, or how many local experiments disappeared without trace. In the long arc of the mystery, Monteverde serves as a southern echo of the northern problem. White Sand says people were deep inside North America during the last glacial maximum. Monteverde says that by at least the later pre-Clovis period, people were far down the western side of the hemisphere, living in ways that do not fit the old Clovis image. Between them stretches of vast missing geography, drowned coasts, buried valleys, tropical passages, mountain corridors, and sites not yet found or not yet accepted. The American story does not begin at one famous place. It emerges from scattered points of light across a dark map. So Monteverde's quiet revolution is not only about a date, it is about the kind of evidence allowed to change history. Mud, wood, plant remains, and modest tools can be as disruptive as the finest spear point. A wet campsite in Chile can force North American archaeology to rethink its beginning. A place far from the presumed doorway can reveal that the doorway was opened earlier than expected, or that there were several doors, some now gone beneath sea and sediment. The site's debates continue, and that uncertainty should not be hidden. But even in uncertainty, Monteverde leaves a lasting mark. It helped pull the first Americans out from behind the Clovis wall and into a continent-sized mystery still unfolding. After Monteverde, the old beginning of the Americas no longer stands where it once did. But the deeper question is more difficult. How far back can the record truly go before evidence thins into ambiguity? It is one thing to move the first secure human presence before Clovis by a few thousand years. It is another to suggest that people may have been in the Americas near 30,000 years ago, or even earlier. That claim does not merely stretch the timeline, it changes the climate problem, the migration problem, the genetic problem, and the archaeological problem all at once. It asks whether human groups entered the hemisphere before the harshest peak of the last glacial maximum, survived through immense environmental stress, and left so few clear traces that only a handful of controversial sites now carry the burden of proof. The number itself has a strange gravity. 30,000 years ago, the world is not yet at the coldest point of the last ice age, but it is moving toward it. Sea levels are lower, Beringia is exposed, northern ecosystems are reorganizing, and ice sheets are expanding across much of northern North America. If people are already south of the ice sheets by then, the simplest post-glacial entry model cannot work. If they are only in Beringia or near the northern threshold, then the question becomes whether they later move south before or during the glacial maximum, and by what route. The evidence remains incomplete, and that incompleteness is exactly why the 30,000-year problem feels less like a discovery and more like a stress test for every method archaeologists use. Chiquihuite Cave in central Mexico is the name most closely tied to this older possibility. high in the mountains of Zacatecas. The cave produced a reported assemblage of stone objects from deep deposits, along with radiocarbon and luminescence dates that were interpreted as evidence for human presence, perhaps around 33,000 to 31,000 years ago, if correct. Chiquihuite would place people in North America far earlier than White Sands, far earlier than Cooper's Ferry, and almost unimaginably earlier than Clovis. It would suggest that the first American story began not at the edge of the last deglaciation, but deep inside an older and colder world. But Chiquihuite also shows why extraordinary claims become battlegrounds. Critics have argued that many of the supposed tools may not be tools at all. The cave's geology may have produced sharp stone fragments through natural processes: roof fall, frost fracturing, sediment movement, pressure, or other breakage. A stone can be angular, sharp, and suggestive without being shaped by human hands. If the stones are artifacts, the timeline opens dramatically. If they are geofacts, then the early dates may belong to old sediments and natural rocks, not to people. Scholars still debate the interpretation, and no single explanation fully accounts for why the assemblage looks the way it does to supporters and skeptics alike. The caution around Chiquihuite is not stubbornness for its own sake. Archaeology has learned, sometimes painfully, that very old American sites can be seductive. The desire to find the first footprint of humanity on a continent can make ordinary rocks look meaningful and damaged bones look intentional. This is why context matters as much as the object. A convincing early site usually needs multiple converging signs, tools with clear manufacturing patterns, use-ware, hearths, food remains, spatial organization, datable material directly connected to human action, and sediments that have not been disturbed. Chiquihuite has dates and stones, but whether it has a securely human signature remains the core dispute. The older the site, the less forgiving the standards become. There are other early claims that orbit the same problem, though not all carry equal weight. Bluefish Caves in Yukon, with argued evidence around 24,000 years ago, is not a 30,000-year claim, but it matters because it places the debate in Beringia during the glacial maximum. If the marks on bones there are truly human-made, they support the idea that people were present in the Northern Gateway long before the continent-wide pre-Clovis record becomes clearer. Yet bluefish also depends on difficult interpretation of cut marks and bone modification, a field where microscopic details matter greatly. Its strongest role may be as part of a wider northern possibility rather than a single decisive proof. Farther outside the mainstream are claims that push human activity much earlier still, sometimes to dates that would require an almost complete rewriting of American prehistory. Sites involving broken mastodon bones, very early stone scatters, or alleged ancient occupation surfaces have periodically drawn public attention. Some are intriguing enough to deserve study, others have not survived critical review. The key issue is not whether early humans were capable of reaching new lands. They were. The issue is whether each specific claim can show that the traces are human, securely dated, and undisturbed. Popular accounts often treat skepticism as a lack of imagination, but in deep archaeology, skepticism is one tool that prevents the past from becoming fantasy. The 30,000-year problem also collides with genetics. Ancient and modern DNA studies broadly support a deep connection between indigenous American ancestry and populations ultimately related to Northeast Asia, with periods of isolation and later diversification. Genetic models can allow for a population history that begins before Clovis, and some versions fit a Beringian standstill before expansion south. But genetics does not simply confirm every archaeological claim. If people were widespread in the Americas by 30,000 years ago, researchers must explain how that presence relates to the ancestry seen in later, ancient remains and present-day indigenous populations. Did those early groups contribute directly? Were they small and later absorbed? Did some lineages vanish? The genetic evidence has become more complex, not less, and it does not yet turn the oldest claims into settled fact. Bayesian modelling has also entered the debate, combining dates from multiple sites to estimate possible arrival and expansion patterns. These models can suggest that human dispersal into North America began before the last glacial maximum, especially if certain early sites are included. But models are only as strong as the data placed inside them. If a controversial site is treated as valid, it can pull the estimated timeline earlier. If that same site is removed, the picture changes. This does not make modelling useless. It makes it revealing. It shows how the argument depends not only on numbers, but on trust in the archaeological meaning behind those numbers. A lesser-known tension is that early populations may have been archaeologically quiet. Small groups moving through vast landscapes can leave little behind. If they use simple flake tools, perishable technologies, coastal camps, or short-lived occupations, their footprint in the record could be faint. This makes it possible, in principle, for people to have been present earlier than the strongest evidence currently shows. But possibility is not proof. The missing record can explain why evidence is scarce, yet it cannot replace evidence. That boundary is where responsible mystery must live. So the 30,000-year mystery remains suspended between two truths. The first is that the old Clovis beginning is gone, and White Sands has made a human presence during the last glacial maximum difficult to deny. The second is that 30,000 years and beyond still rests on more contested ground. Chiquihuite may yet prove to be a window into an astonishingly early occupation, or it may become a cautionary tale about how caves can deceive. Bluefish may preserve northern traces of people waiting in Beringia, or it may remain an argument over marks on bone. The record is not empty, but neither is it settled. The deeper the timeline goes, the more the story asks not only what ancient people did, but how modern science can recognize them when the clearest signs have not survived. The difficulty with the world before Clovis is that it often refuses to leave a signature. Clovis points announce themselves with almost ceremonial clarity. They are fluted, shaped with control, made to a pattern recognizable across enormous distances. An archaeologist can hold one and know, with a fair degree of confidence, that it belongs to a particular technological tradition near the end of the Ice Age. Pre-Clovis tools are not always so generous. They may be smaller, simpler, more varied, more local, or made for tasks that do not produce dramatic museum objects. They may not look like the beginning of a continent-wide story. They may look like ordinary flakes of stone. This is a deeper problem than it first appears. Archaeology depends on pattern recognition, but the earliest people in the Americas may not have shared a single pattern. If small groups entered through different routes, paused in different environments, used different raw materials, and adapted to different prey, plants, and seasons, their toolkits could have been highly diverse. A family living near a Pacific shoreline might need cutting flakes, scraping edges, bone points, cordage, nets, digging sticks, and watercraft parts. A group in an interior river valley might need projectile points, knives, hide-working tools, plant processing tools, and heavy implements for bone or wood. A camp beside a lake in the southwest might leave footprints and scattered stone. but not the kind of object that makes a clear cultural label possible. The strange irony is that Clovis may be easier to find partly because it came later and became widespread. Earlier technologies could have been more experimental, more regionally distinct, or less standardized. Some may have been excellent for survival while leaving very little that survives in the ground. Stone dominates the archaeological record because it endures, but stone was probably only one part of daily technology. Wood, hide, sinew, plant fibre, bone, antler, ivory, and shell could all have mattered deeply. A spear shaft, woven bag, net, basket, cord, handle, mat, or skin covering may have been as important as any chipped point, but most of these materials disappear unless preservation is unusually kind. What survives is not a complete toolkit, it is the hard skeleton of one. This makes early sites difficult to compare. At Cooper's Ferry, the stone tools include stemmed projectile points and other artifacts that do not resemble Clovis fluted points. Their presence around 16,000 years ago suggests that technological traditions older than Clovis were already established in parts of North America. Some researchers have noted broad similarities between certain stemmed forms in the Americas and older technologies around Northeast Asia or Japan. But such comparisons require caution. Shapes can converge. People facing similar tasks can invent similar solutions. A stemmed point in one region does not automatically prove direct descent from another region thousands of kilometers away. Still, these similarities are worth studying because they may preserve faint traces of movement across the northern Pacific world. Other sites show the problem from another angle. At the Debrael Friedkin site in Texas, tools below Clovis layers show that people were making and using stone implements before the famous fluted point tradition appeared there. This does not mean Clovis emerged directly from these tools in a simple line, but it does suggest a technological landscape already occupied by older traditions. The ground, in that case, literally places pre-Clovis beneath Clovis, turning sediment into an argument. Yet the artifacts themselves are often less instantly recognizable to the public. They lack the iconic shape that made Clovis so persuasive. They have to be understood through context, dating, stratigraphy, and analysis rather than immediate visual drama. At Chiquihuite Cave, the issue becomes more severe. The reported stone objects are central to the claim of a very early human presence, but critics argue that many may be naturally broken rock. This is the nightmare edge of early tool studies, the border between artifact and geofact. A human-made flake usually shows traits such as a striking platform, bulb of percussion, controlled fracture, repeated removals, and patterns consistent with deliberate reduction. But natural forces can create sharp stones too. Gravity, pressure, frost, cave collapse, and sediment movement can fracture rock in ways that look suggestive. The older and more unusual the assemblage, the more carefully it must be separated from geology. The same caution applies to simple flake tools in open sites. A flake can be enough if it comes from a secure context and shows the right features, but isolated flakes are fragile evidence. A scatter of flakes is stronger when it includes refitting pieces, cores, useware, spatial patterning, and association with hearths or food remains. Useware analysis can reveal polishing, edge damage, or microscopic traces from cutting hide, meat, plant material, wood, or bone. But these studies require careful comparison and can still be debated. Residue analysis may detect ancient plant or animal traces, yet preservation and contamination complicate the picture. No method speaks alone. The strongest cases come when several weak voices become one steady chorus. There is a lesser-known issue of raw material. Early people did not always have access to perfect stone. They used what landscapes offered: chert, obsidian, quartzite, basalt, chalcedony, jasper, or poorer local materials when nothing better was nearby. Some rocks fracture cleanly and preserve deliberate flaking beautifully. Others fracture stubbornly, producing crude-looking tools that can be dismissed too quickly. A toolkit made from difficult stone may look less refined, not because its makers lacked skill, but because the material resisted elegance. In a new continent, finding reliable stone sources would have been part of learning the land. Tools also travel in complicated ways. A fine point might be carried for weeks, repaired many times, lost far from its source, or deposited in a place unrelated to where it was made. A rough flake might be made, used, and discarded within minutes. Some camps produced dense evidence because people stayed, repaired tools, processed food, and returned repeatedly. Other places produce almost nothing because people pass through lightly. The absence of a signature tool tradition does not mean absence of people. It may mean their activities were brief, their technology was perishable, or their stone tools were too ordinary to survive recognition without excellent context. The search for pre-Clovis technology therefore asks researchers to loosen one habit without abandoning rigor. They must stop expecting the first Americans to look like Clovis, while still demanding proof that older traces are genuinely human. That balance is difficult. Too much skepticism can erase real early evidence because it does not match familiar forms. Too much enthusiasm can turn natural fragments into a false human presence. Scholars still debate where that balance should fall, especially at the oldest and most controversial sites. The deeper lesson is that the first Americans may not have had one archaeological face. They may have left many small signatures, stemmed points in one region, simple flakes in another, bone and ivory tools in the north, plant processing tools in wet environments, shell or wood technologies along coasts now underwater, footprints where mud preserved movement better than artifacts. Clovis was a bright flare, not necessarily the first spark. Before it, the technological record may have been dimmer, scattered, and more local, but not empty. To see it, archaeology has to learn to read quieter marks, the kind that do not shout from a display case but remain buried in sediment, waiting for context to give them a voice. Before Clovis becomes visible in stone, before the fluted points spread across the continent like a recognizable signal, there are people living inside landscapes that have not yet become historical places. They are not symbols of migration. They are not arrows moving down a map. They wake in cold air, watch weather, remember water, repair tools, follow tracks, carry food, choose camps, avoid dangerous ground, and learn a continent by surviving one decision at a time. The first Americans' puzzle is often told through dates, routes, and discoveries. But the people behind those arguments were not living inside a timeline. They were living inside days. Their world is practical before it is mysterious. A group moving through late Ice Age North America must know where stone can be found. But stone alone is not enough. They need fuel, shelter, dry ground, water that can be reached safely, animal movement patterns, edible plants, and places where the wind is less punishing. They need clothing suited to cold seasons and repairable when torn. They need containers, cords, bindings, cutting edges, scrapers, points, digging tools, and knowledge of how each material behaves. Much of this technology disappears because it is made of things that rot: wood, bark, hide, sinew, grass, root fibre, feather, bone, antler, ivory. The archaeological record preserves the hard leftovers of a much softer and more complete world. A camp may not have looked permanent, but it would not have been careless. People who move often still organise space. Fire belongs where smoke can rise and heat can be shared. Stoneworking may happen in one area so sharp, flakes do not scatter underfoot. Food preparation may happen near water or on clean surfaces. Sleeping places need protection from damp ground and wind. Hides may be stretched, tools repaired, meat dried, roots processed, wood shaped, points resharpened. What survives in the record suggests that even short occupations can leave patterns, but those patterns are fragile. A few hours of work can vanish under a season of flooding. A week of life can become a stain, a scatter, a lens of charcoal, or nothing at all. Food would have required flexibility. The old image of early Americans as only big game hunters is too narrow. Large animals mattered, especially in open landscapes where mammoths, horses, camels, bison, or other prey move through seasonal ranges, but survival rarely depends on one food source alone. People also likely gathered plants, seeds, roots, berries, nuts where available, eggs, fish, shellfish, small animals, birds, and other resources depending on region and season. In wetlands like the ancient margins of Lake Otero, plant and animal resources would have changed with water level. Along coasts, marine foods may have mattered deeply. In forests, plant knowledge and smaller game could be just as important as encounters with large animals. No single explanation fully accounts for the diversity of environments early people entered. The hunting itself should not be imagined only as dramatic charges against giants. Humans are endurance thinkers as much as weapon makers. They observe trails, dung, broken branches, feeding grounds, water crossings, seasonal habits, and the behavior of predators. They scavenge when safe, hunt when possible, trap or ambush where terrain helps, and avoid risks that do not repay the danger. Large animals are valuable, but costly. A mammoth is not simply food. It is a massive, dangerous animal embedded in a social and ecological world. Even after a successful kill or scavenging event, the work continues cutting, carrying, drying, rendering fat, breaking bone from marrow, using hide, sinew, bone, and ivory. The animal becomes meals, tools, coverings, bindings, and memory. One lesser-known detail is how important fat may have been in Ice Age diets. Lean meat alone is not enough for long-term survival, especially in cold environments where calories are burned quickly. Animal fat, marrow, brain tissue, and stored energy sources can be crucial. This does not make the past crude or grotesque. It makes it precise. People knew which parts of animals mattered most, when animals were lean, when they were rich, how to process food so they lasted, and how to avoid wasting materials in a world where waste could become hardship. Archaeology sometimes finds broken bones and reads them as evidence of marrow extraction, but behind that technical phrase is an intimate knowledge of nourishment. Plant knowledge is harder to see but may have been just as essential. Seeds, tubers, bulbs, fruits, greens, inner bark, medicinal plants, and fibers all require identification and timing. Some plants are edible only after processing. Some are useful for cordage, mats, baskets, nets, bedding, fire starting, or binding. A stone scraper may survive, while the basket it helped make is gone. A grinding stone may be found, while a seasonal harvest it served is invisible. The evidence remains incomplete because plants leave fewer traces than stone and bone unless preservation is exceptional. Yet any realistic picture of early life must include them. not as background scenery but as active knowledge carried across generations. Movement through the continent would have followed memory as much as hunger. People remember where a river can be crossed, where obsidian or chert lies exposed, where animals pass in late season, where storms gather, where shelter can be found if weather turns, where old camps remain useful, and where death or danger should be avoided. These remembered landscapes could spread through stories, teaching, repeated travel, and social connection. A route is not merely a line between 2 points. It is a chain of known places. For early Americans entering new regions, every route had to be built from observation, and every mistake could reshape future choices. Social life is almost invisible archaeologically, but it is the foundation of survival. People share labor, watch one another, teach skills, maintain bonds, exchange information, and make decisions that balance movement with rest. Children, when present in the community, would have been protected and taught through daily life rather than treated as separate from the group's rhythms. Older people may have carried memory of places, seasons, techniques, and past dangers. Skilled toolmakers, trackers, gatherers, healers, and navigators may not leave individual signatures, but their knowledge is embedded in the fact that the group survives at all. Deep prehistory often preserves objects, while the social intelligence behind them remains just out of reach. The first Americans were also entering landscapes filled with other predators: saber-toothed cats, American lions, dire wolves, short-faced bears, and other carnivores would have shaped where people camped, how they stored food, and how they moved at night or near carcasses. Humans were formidable, but not invulnerable. Fire, group awareness, dogs in later contexts, weapons, and careful camp placement all matter in a world where the smell of meat can draw attention. The record rarely preserves fear directly, but it preserves the need for strategy. Living among large carnivores requires reading not only prey animals, but competitors. At places like White Sands, the tracks remind us that movement could be ordinary and repeated. At Cooper's Ferry, tools suggest people knew river landscapes well enough to return and work there. At Page Ladson, submerged evidence hints at people using environments now hidden by water. Across these places, daily life appears not as one grand migration, but as a patchwork of local knowledge. The first Americans were not simply discovering a continent. They were turning unfamiliar ground into lived territory. One camp, one shoreline, one river bend, one season at a time. This is why the mystery remains so powerful. Dates can tell when people were present. Tools can tell what they made. Bones can hint at what they ate. Footprints can show where they walked. But the inner life of adaptation, the full texture of how they knew the land, survives only in fragments. Scholars still debate the timing and roots, but the human reality behind the debate is clear enough to feel people endured, learned, and belonged to these places long before the old Clovis horizon. Their lives were not preliminary. They were the story already underway. A story already underway still has to explain how people reach so many different worlds. The traces are scattered across lake basins, river terraces, caves, submerged sinkholes, northern valleys, and southern wetlands. But between those traces lie the great blank spaces of movement. Someone had to cross thresholds. Someone had to find openings through ice, along water, around mountains, across plains, and into ecosystems that were not yet familiar. The route into the Americas is therefore not a single line waiting to be drawn. It is a set of possibilities shaped by climate, sea level, survival, and the stubborn fact that the most likely paths are often the hardest to prove. The inland ice-free corridor once carried much of the story. It seemed reasonable because it placed people between the Laurentide and Cordilleran ice sheets after they began to separate, creating a passage from Alaska and Yukon into the interior of North America. In the older Clovis-first model, this corridor was the Great Gate. People crossed Beringia, waited for the ice to open, moved south through the passage, and then spread across the continent. It was tidy, geographical, and easy to picture, but a corridor on a map is not automatically a human road. For people to pass through, it must offer more than absence of ice. It must have animals, plants, fuel, water, shelter, and enough ecological stability to support travel over long distances. That is where the corridor became less certain. Geological and paleoecological studies have suggested that while parts of the corridor may have opened physically, it may not have become biologically useful early enough to explain the oldest pre-Clovis sites. A newly exposed landscape can be raw, wet, unstable, poor in vegetation, and difficult for large animals to use. Without animals and plants, there is little for people to follow or eat. This does not make the corridor irrelevant. It may have mattered greatly for later movements, including movements connected to Clovis and post-Clovis populations, but it struggles to carry the full weight of a human presence at White Sands around 21,000 to 23,000 years ago, and it becomes even harder to use if one accepts older claims approaching 30,000 years. The coastal route answers some of those problems while creating others. Along the Pacific margin, people may have moved south through a chain of coastal refugia, marine resources, islands, estuaries, and shoreline habitats. This route does not require waiting for the interior corridor to become fully livable. It also fits the possibility that people reached far southern regions early, because coastlines can guide movement across long distances without requiring immediate penetration into every inland environment. A group familiar with fishing, shellfish gathering, seaweed harvesting, boats, and coastal navigation could move in pulses along an edge rich with predictable resources. The image is powerful because it turns the ocean from a barrier into a path, yet the coast keeps its evidence underwater. During the Ice Age, sea level was much lower, and the shorelines that mattered most were often far beyond the modern beach. When the ice melted and the seas rose, those ancient camps, if they existed, were drowned. Some may have been destroyed by wave action long before anyone could find them. Others may survive under marine sediment, but locating them is difficult, slow, and expensive. This means the coastal hypothesis lives with an unusual imbalance. It may be one of the best explanations for early movement, and yet much of the evidence needed to prove it may be hidden in places archaeology can barely reach. The evidence remains incomplete, not because the idea is weak by definition, but because the landscape itself has been removed from sight. A third idea sits farther north and deeper in time: the Beringian standstill. Under this model, ancestors of indigenous Americans spend a long period isolated or semi-isolated in Beringia before expanding into the continents. This helps explain genetic patterns suggesting separation from Asian source populations before the later diversification of Native American lineages. It also fits the environmental reality that Beringia was not simply a bridge, but a habitable region with its own resources. People may have lived there for thousands of years, adapting to northern conditions, while glaciers and changing climates blocked or limited movement farther south. In this view, the peopling of the Americas begins not with a sudden crossing, but with a long pause in a vanished land. The standstill does not solve everything. It explains where a population might have been waiting, but not exactly when and how different groups moved south. It must be connected to one or more exit routes inland when possible, coastal when possible, perhaps both at different times. It also faces the same problem of drowned evidence. Because much of central Beringia now lies beneath the sea, if generations lived on exposed lowlands now covered by water, then the archaeological heart of the standstill may be missing. Genetics can suggest the shape of population history, but it cannot point to every campsite or tell which shoreline a family followed. The strongest picture may not require choosing only one route. Human movement rarely obeys the simplicity of later diagrams. Some groups may have moved along the coast earlier, while others remained in Beringia or later used inland corridors. Some movement may have failed, paused, or left no descendants. Some groups may have expanded south, split into regional populations, and then interacted again as climate shifted. Ice sheets did not open all doors at once. Coastlines did not offer equal resources everywhere. River systems could draw people inland from the coast. Interior routes could later connect populations that had once been separate. No single explanation fully accounts for all of this, and perhaps no single route ever existed as the route. The timing of evidence forces this flexibility. White Sands places people deep in North America during the last glacial maximum, when the simplest late corridor model is inadequate. Cooper's Ferry suggests early people in the interior northwest before Clovis, in a position that may connect more comfortably to Pacific movements than to a late ice-free corridor. Page Ladson shows people in the southeast by about 14,550 years ago, in a very different ecological world. Monteverde, despite renewed debate over details, remains part of the broader reason researchers look seriously toward western and coastal dispersals. Chiquihuite, if its disputed evidence were accepted, would demand an even earlier and more complex route story. But each site carries its own uncertainty, and the route model must be built from the best supported pieces without forcing every clue into one neat chain. There is also the possibility of movement within the Americas that was just as important as movement into them. Once people were south of the ice sheets, they did not simply fan out evenly. They followed rivers, coastlines, animal herds, mountain passes, wetlands, and seasonal resources. They may have moved quickly through some regions and lingered in others for generations. Tropical forests, deserts, highlands, plains, and cold southern environments each required different strategies. A population reaching one region early does not mean all neighbouring regions were immediately occupied. The continent was not filled like water poured into a bowl. It was learned unevenly. The old migration map often used arrows because arrows make movement look purposeful and clean. But the real movement may have been more like smoke, spreading where air allowed, curling back where barriers stood, thinning in harsh places, gathering in sheltered ones. Ice and water shaped the openings. Sea level erased the edges. Climate rearranged the resources. People responded with intelligence, patience, and risk. The routes through ice and water remain debated because they were never fixed roads. They were changing relationships between humans and landscapes, and only a few fragments of those relationships have survived. By the time the evidence becomes clearer, the deepest movements are already behind the visible record. Clovis appears as a bright technological horizon. Pre-Clovis sites emerge as scattered lights before it. White Sands reaches farther back into the glacial world. Beringia waits behind them all, partly drowned. The coast runs like a missing line along the map's edge. The corridor opens later with its own importance. Together they suggest not one entrance, but a long unfolding of possibilities, shaped by ice when it blocked the land and by water when it hid the path. The routes through ice and water leave one kind of trace in sediment, but another kind survives inside people. Long after camps erode, shorelines drown, and tools lose their context, ancestry can remain written in genomes, scattered across chromosomes in patterns of inheritance, separation, mixture, and survival. For a long time, the peopling of the Americas was argued mainly through artifacts and geology. Stone points, cave layers, animal bones, glacial maps, and radiocarbon dates carried most of the weight. Then DNA entered the story, and the old questions did not disappear. They became sharper. Genetics changed the first Americans' puzzle because it showed that the beginning was not likely to be a simple single march from one place to another. Modern indigenous peoples of the Americas share deep ancestry connected ultimately to ancient populations of Northeast Asia. But that ancestry does not look like a recent uncomplicated branch. It suggests separation, isolation, diversification, and later movement. The ancestors of Native American peoples appear to have split from related Asian populations before spreading widely through the Americas, and one explanation for that gap is a long period in or near Beringia. The Beringian standstill, once an idea built partly from climate and geography, gained new weight because genetics seemed to preserve the shadow of a population waiting at the edge of two continents. Ancient DNA made the shadow more tangible. Remains from Alaska revealed an ancient Beringian lineage, showing that not all northern peoples contributed to later populations in the same way. Some lineages branched early and did not become the direct source of most later indigenous American ancestry, at least as currently understood. This is important because it makes Beringia look less like a single hallway and more like a region of population structure. People could live near one another, share distant ancestry, and still follow different demographic paths. Some groups expanded, some remained. Some left only faint genetic traces. Some may have disappeared from the surviving record altogether. Farther south, ancient genomes helped confirm that people related to later indigenous Americans were already widespread soon after the pre-Clovis period. The genome of an infant associated with the Clovis period in Montana showed a strong connection to later Native American populations, making clear that Clovis people were not outsiders unrelated to indigenous history. But the genetics also showed that Clovis was not the beginning of that ancestry. It was one moment within a deeper population history already unfolding. Stone tools had once made Clovis look like the origin. DNA made it look more like a visible flare within an older lineage. The story becomes even more complex in Central and South America. Genetic studies have revealed early branching, rapid dispersal, regional differentiation, and later reshaping of populations. Some ancient individuals in South America show close relationships to early North American ancestry, while others reveal movements and replacements that happened after the first settlement. Large modern genomic datasets from indigenous communities, including recent work focused on Latin America, have deepened the picture further by showing that the genetic landscape of the Americas cannot be reduced to one clean wave. It contains layers: old ancestry, local continuity, later migration, isolation in some regions, contact between others, and histories shaped by geography as much as by time. One surprising detail is how fast the initial diversification may have been once people were south of the ice sheets. Genetic patterns suggest that some ancestral lineages spread through the Americas rapidly enough to reach far southern regions early, which fits the archaeological pressure created by pre-Clovis sites. But rapid does not mean simple. A population can expand quickly along a coast or through favourable corridors and still take generations to learn local environments. The DNA may show branching events, while archaeology shows camps, tools, footprints, and food remains. One record speaks in inheritance, the other speaks in behaviour. They do not always use the same clock. There are also signals that remain debated. Some studies have reported traces of ancestry in certain indigenous South American groups that appear distantly related to Australasian or related populations, a pattern sometimes discussed under the idea of a deeply complex source population. This has attracted public attention because it sounds like evidence for a separate dramatic migration across the Pacific, but scholars remain cautious. The signal is small, its interpretation is difficult, and it does not support simple popular stories of lost fleets or unsupported oceanic colonization. It may reflect ancient population structure in Asia before the ancestors of Native Americans moved into Beringia, or another process not yet fully resolved. The evidence remains incomplete, and genetics here offers a puzzle rather than a finished answer. The same caution applies to using DNA to judge archaeological claims around 30,000 years. Genetics can allow for deep separation before the spread through the Americas, but it does not automatically prove that people were living in Mexico, New Mexico, or South America at that early date. If a site claims human presence around 30,000 years ago, genetics asks hard questions. Were those people ancestors of later indigenous populations? Did they represent an early branch that left no detectable descendants? Could a small population survive for thousands of years with little archaeological visibility, or is the archaeological claim itself mistaken? No single explanation fully accounts for all possibilities, and the DNA does not rescue weak artifacts from weak contexts. This is where white sands become so important again. The footprints do not provide DNA, but their age forces genetics and archaeology into conversation. A human presence around 21,000 to 23,000 years ago in New Mexico means that the ancestral story must include enough time for people to enter and live south of the ice sheets before that moment. Genetic models that allow an earlier split and Beringian isolation can accommodate that more comfortably than the old Clovis-first model. But if claims go much earlier, toward 30,000 years or beyond, the fit becomes more demanding. The deeper the proposed occupation, the more explanation is needed for why later genetic patterns look the way they do. Later population movements also matter. The Americas were not settled once and then frozen in place. Arctic and subarctic regions saw later migrations, including ancestors related to Paleo-Inuit and Inuit populations. And Nardini-speaking groups have complex northern histories involving additional ancestry components. Within the Americas, populations moved, mixed, separated, and adapted to mountains, deserts, forests, coasts, plains, and islands. The genetic story is not a single origin myth. It is a living record of many histories, some ancient and some more recent, all layered over the first peopling. There is a responsibility in telling this part of the story. Indigenous peoples are not evidence samples. They are living communities with their own histories, identities, rights, and relationships to ancestral remains. Modern genetics has often depended on cooperation, consent, and careful ethical practice, and it also carries a history of misuse when communities were treated as subjects rather than partners. The science can reveal astonishing details about deep ancestry, but it cannot replace indigenous memory, sovereignty, or cultural knowledge. What it can do, when handled carefully, is add another line of evidence to a story that was never only archaeological. DNA has not solved the first Americans' puzzle. It has made the puzzle deeper and more disciplined. It supports a connection to Northeast Asia, a period of separation, a likely Beringian chapter, and rapid early diversification through the Americas. It complicates any simple one-wave model. It challenges claims that cannot fit population history. It also leaves room for missing lineages, lost branches, and movements too small or too ancient to detect clearly. Like footprints, genomes preserve presence without explaining everything. They do not show the face of the first person to cross a vanished shoreline. They do not show the campfire, the weather, the fear of ice, or the choice to keep moving. But they do show that the people who entered the Americas carried a history already thousands of years old, and that their descendants would become part of one of the most complex human stories on Earth. The deeper the first American story moves into time, the more it becomes a story of loss, not only the loss of people, animals, climates, and worlds, but the loss of evidence itself. Archaeology often feels as though it is discovering the past, but just as often it is arriving after the past has been damaged almost beyond recognition. A footprint survives in one basin because mud, chemistry, burial, and chance align. A camp disappears a few kilometers away because wind strips the surface clean. A cave protects deposits for millennia, then confuses them with roof fall and sediment movement. A shoreline feeds generations. Then the sea rises and takes the entire landscape out of reach. The oldest American story may not be hidden because people were rare. It may be hidden because the places that held them were fragile. Sea level is one of the great thieves. During the last ice age, when so much water is locked in glaciers, coastlines extend far beyond their modern edges. The Pacific shore, the Gulf margins, parts of the Atlantic coastal plain, and the exposed lands around Beringia all look different. Places that now seabed may once have been beaches, lagoons, marshes, estuaries, river mouths, campsites, shellfish beds, and travel corridors. If early people moved along these coasts, their best evidence may now lie underwater, buried beneath marine sediment or destroyed by waves as the ocean advanced. This is not a minor gap. It may remove whole chapters from the record, especially if coastal movement played a major role before inland evidence became more visible. The drowning of Beringia is especially painful for the story. A region that may have held ancestral populations for thousands of years is now mostly absent from ordinary excavation. The land between Siberia and Alaska was not merely a crossing point. It may have been a homeland, a refugium, a place where people learned northern seasons and waited through climatic pressure. If camps, tool-making areas, hunting stations, or repeated gathering places existed on the exposed lowlands, many are now beneath the Bering and Chukchi seas. Genetics can suggest that something important happened there, but archaeology must work mostly along the edges. The center of the stage is underwater. Ice destroys in a different way. Glaciers grind landscapes with extraordinary force, scraping bedrock, crushing deposits, moving boulders, burying valleys, and reworking sediments. In regions covered by ice sheets, older archaeological traces may be erased entirely. Near glacial margins, meltwater can carve channels, flood lowlands, and deposit thick layers of sand, gravel, and silt over earlier surfaces. A human presence near ice might leave little behind if the glacier later advances or if meltwater rearranges the landscape. The absence of sites in such places may reflect destruction, not absence of people. Yet this cannot be assumed too easily. Scholars still debate where missing evidence should be treated as meaningful and where it should be treated as the predictable result of geological violence. Rivers are both guides and erasers. People tend to live near water, and rivers offer movement, fish, animals, plants, stone exposures, and repeated stopping places. But rivers shift. They cut banks, flood terraces, bury camps under meters of sediment, or carry artifacts far from their original positions. A site sealed under alluvium may survive beautifully, hidden until erosion or construction exposes it. Another may be destroyed before anyone knows it existed. The same river that made a place livable can later tear the evidence apart. This is why some early sites appear as lucky exceptions rather than continuous records. The missing spaces between them may once have held many more traces. Open landscapes can be just as unforgiving. Wind removes fine sediment. Deserts expose and scatter artifacts. Soils develop, dissolve, or mix materials through root growth and animal burrowing. Freeze-thaw cycles crack stone and bone. Fire alters surfaces. Later human activity, from agriculture to roads to cities, can disturb or cover ancient deposits. In some cases, archaeological evidence may be sitting in plain sight, but without enough context to prove its age. A stone tool found on the surface may be ancient, or it may have been moved, reused, or deposited much later. Without secure layers, dating becomes difficult. The object survives, but its time is lost. There is also the problem of recognition. The earliest traces may not look like what researchers expect. Before Clovis, tools may be simple, local, and varied. A small flake from a brief camp may not attract attention. A hearth may look like a stain. A plant processing area may leave microscopic residues rather than obvious artifacts. A coastal campsite made mostly from wood, fibre, bone, and shell may vanish almost completely if preservation is poor. Archaeology can miss evidence not because it is absent, but because it does not match the search image. This was one of the lessons of the Clovis-first era. A powerful model can focus attention, but it can also narrow vision. At the same time, misrecognition can move in the other direction. Natural stones can look worked, broken bones can look butchered, burned patches can look like hearths. A cave can create sharp fragments through collapse and pressure. A river can concentrate objects in ways that seem patterned. This is why the oldest claims produce such intense debate. Chiquihuite Cave, Bluefish Caves, and other contested sites are not simply arguments over dates. They are arguments over how the past can imitate human activity. The evidence remains incomplete because the record is not a clean archive. It is a damaged archive full of coincidences, traps, and partial truths. Even strong sites are not immune to later reassessment. New dating methods, improved sediment studies, microscopic analysis, ancient DNA, and better environmental reconstruction can strengthen a claim or weaken it. White sands has grown more persuasive as researchers have tested its chronology in new ways. Monteverde, long a pillar of pre-Clovis archaeology, has returned to debate because new interpretations challenged old assumptions and specialists responded forcefully. This is not a failure of science. It is the process by which deep history remains alive. A site is not accepted once and then sealed forever. It continues to be measured against new tools and new questions. The first Americans themselves may also have left uneven traces because their populations were small. A few hundred or a few thousand people spread across enormous landscapes would not create dense archaeological visibility. Their camps might be brief, their tools might be curated, repaired, carried away, or made from perishable materials. Their movements might follow coasts now drowned or river corridors later destroyed. A population can be real and still nearly invisible for long stretches of time. No single explanation fully accounts for every gap, but small population size, mobile life, changing landscapes, and poor preservation together can make the early record appear thinner than the human presence actually was. And yet absence cannot be allowed to do all the work. It is tempting to fill every blank with imagined camps and lost routes, but responsible archaeology must stop where evidence stops. The missing coast may explain why coastal sites are scarce. It does not prove any specific migration. Destroyed landscapes may explain why early sites are rare. They do not prove a 30,000-year occupation everywhere. The mystery is powerful because it sits between possibility and proof. Too much certainty would flatten it. Too much speculation would dissolve it. What remains is a continent of partial windows. White Sands opens onto a vanished lake. Cooper's Ferry opens onto an early river world. Page Ladson opens beneath dark water. Bluefish opens into a debated northern threshold. Chiquihuite opens into a cave where geology and archaeology wrestle over the same stones. Beringia opens mostly through absence, genetics, and drowned land. Each window is narrow, but together they show that the old beginning was too late and too simple. The first Americans are not missing because they were unimportant. They are missing because time is not a library. It is weather, water, ice, pressure, chemistry, and chance. It keeps some footsteps and erases whole coastlines. The first American's puzzle remains unfinished because every answer opens another layer beneath it. Clovis is no longer the beginning, but removing that old beginning did not reveal a single older one waiting neatly below. Instead, the record widened into a landscape of footprints, disputed cave stones, river camps, submerged sites, genetic branches, drowned coasts, and glacial maps that do not always agree with one another. The story has become more accurate because it is less simple. It no longer asks only when people arrived. It asks how many movements there were, where they paused, what routes vanished, which early populations endured, which left no visible descendants, and how archaeology can recognize human lives when time has stripped them down to fragments. White Sands now stands near the center of that unfinished story, because it gives the past an almost bodily immediacy. Human tracks in New Mexico, dated to around 21,000 to 23,000 years ago, place people in North America during the last glacial maximum, in a world where the old late-entry model struggles to breathe. The footprints do not prove every older claim, and they do not solve the 30,000-year mystery by themselves, but they change the scale of the question. If people were walking beside Lake Otero, then their ancestors had already crossed into the American world earlier. They had already found routes, learned landscapes, and lived through conditions once thought too difficult for the old model to allow. Beyond White Sands, the evidence forms a hierarchy of confidence and debate. Cooper's Ferry, Page Ladson, and the Deborah L. Friedkin site help show that pre-Clovis occupation was real in multiple regions before the famous fluted point spread. Monteverde, despite renewed argument over details, remains part of the deeper shift that forced researchers to take early South American settlements seriously. Bluefish Caves keeps the northern Beringian question alive, though its evidence is weighed carefully. Chiquihuite Cave holds the most dramatic possibility of all, perhaps pointing toward human presence around 30,000 years or more. Yet it also carries the heaviest uncertainty because scholars still debate whether its stones are true artifacts or natural fragments shaped by cave processes. The evidence remains incomplete, and that incompleteness is not a weakness to hide. It is the true shape of the field. The legacy of the pre-Clovis debate is therefore not one overturned dogma replaced by another. It is a lesson in how beginnings are made and unmade. Clovis-first once seemed strong because it was based on real evidence. The mistake was not recognizing Clovis as important. It was mistaking visibility for origin. Clovis tools were distinctive, widespread, and datable. Earlier people may have left technologies less standardized, more local, more perishable, or more difficult to identify. They may have lived along coasts now drowned, in landscapes later scraped by ice, beside rivers that shifted, or in camps so brief they left only a few flakes and fading stains. The first culture that archaeology can easily see is not necessarily the first culture that lived. Genetics has made this lesson even sharper. DNA links indigenous American ancestry deeply to populations ultimately connected with Northeast Asia, while also suggesting isolation, branching, rapid diversification, and later movements across the hemisphere. It gives weight to a Beringian chapter, perhaps a long pause in a vanished northern world. It shows that the peopling of the Americas was not a single clean wave frozen forever in place. But DNA also warns against easy stories. It does not automatically validate every early archaeological claim. It cannot make a natural stone into a tool or turn an uncertain layer into a campsite. It speaks powerfully at the scale of populations, while archaeology must still prove what happened at the scale of a fire, a footprint, a cut mark, or a broken edge. There is also an ethical legacy, one that belongs in the center of the story rather than at its margins. The first Americans are not merely a scientific problem. They are the ancestors of living indigenous peoples whose histories did not begin when archaeologists named a culture or dated a layer. Research into ancient remains, DNA, and migration must be handled with respect for descendant communities, sovereignty, cultural knowledge, and the fact that scientific timelines are only one way of understanding deep connection to land. The archaeological record may speak in sediments and stone, but the human story continues in living nations, languages, traditions, and relationships to place. Any account that treats the first Americans as vanished specimens misses the most important survival of all. The 30,000-year question will probably not be settled by one discovery that ends the debate forever. It is more likely to change through accumulation more carefully dated footprints, more underwater surveys of drowned shorelines, more sediment DNA, more refined dating methods, more ancient genomes studied in ethical partnership, more excavations in places that were once ignored because they did not fit the old model. A cave may become more convincing or less. A submerged landscape may produce a campsite. A river terrace may reveal tools beneath known horizons. A genetic study may expose a branch no one expected. Each new trace will not simply add a date, it will alter the map of possibility. What survives in the record already suggests that the Americas were inhabited before Clovis by people who were adaptable, mobile, observant, and diverse in their ways of living. They were not shadows waiting for a famous tool tradition to give them form. They were real communities moving through Ice Age worlds, learning shorelines, lake basins, forests, plains, wetlands, and mountains. Some may have contributed directly to later populations. Some may have been absorbed into larger histories. Some may have left little that can be detected now. No single explanation fully accounts for their arrival, movement, and visibility. Because the story is not a single event. It is a long human process stretched across climates and continents. The puzzle remains unfinished because the beginning of America is not a point. It is a horizon that keeps receding as evidence improves. Once, that horizon stood at Clovis. Then it moved to Monteverde and other pre-Clovis sites. Then white sands pushed the living presence of people deeper into the Ice Age. Beyond that, Chiquihuite and other controversial claims gesture toward an older darkness that may or may not contain human traces. The honest story must hold both wonder and restraint. It must allow the mystery to remain mysterious without filling every gap with certainty. It must admit that some early chapters may be lost forever. And perhaps that is why the footprints matter so much. They do not complete the story. They remind us what kind of story it is. A person steps into mud beside a lake. The foot lifts. The body moves forward. The moment should vanish, as most moments do. Instead, the ground keeps it. Thousands of years later, that small pressure unsettles an entire continent's timeline. The first Americans remain unfinished not because the story lacks evidence, but because the evidence is still arriving from under sand, under water, under ice, and under old assumptions. The beginning is no longer a wall. It is a field of tracks leading into distance. The story slows here, not because the mystery is solved, but because the oldest human traces ask for quiet. A footprint does not argue. It does not explain its maker's route, language, memory, or name. It simply remains, held in the earth after the body is gone. Around it, the Ice Age world continues to move in imagination, a lake shining where desert now spreads, mammoths crossing the basin, wind combing the open ground, distant mountains holding the last light of a colder sky. The first Americans were not walking into prehistory. They were walking through their present. The world was immediate to them: weather, hunger, warmth, distance, kinship, danger, shelter, the next ridge, the next stream, the next season. Only later do their lives become a puzzle of dates and routes, a debate over corridors, coastlines, genomes, stone flakes, and cave layers. What was ordinary to them has become almost unreachable to us. Time is not gentle with human stories. It sinks coasts beneath the sea. It breaks caves. It scatters bones. It scrapes valleys with ice and lets rivers cut away the places where people once slept. It preserves a few things almost by accident: a tool under sediment, a seed near a track, a mark on bone, a buried surface, a strand of ancestry carried forward through generations. From these remnants, a larger story has to be rebuilt carefully, without pretending the missing parts are not missing. And still, something survives. Not enough to close the mystery, but enough to change its shape. The Americas were not first entered at the moment a famous spear point appeared. The human story was already older, deeper, and more complicated. People had already crossed thresholds, learned unfamiliar lands, and left traces in places that later became desert, riverbank, forest, sea floor, and memory. So the final image is not a map with an arrow. It is not a monument or a victory of one theory over another. It is a pale basin after rain, the surface soft enough to receive a step. Someone walks across it and continues beyond the edge of what can be known. The print remains behind, shallow and fragile, while the person disappears into the Ice Age distance, carrying the rest of the story with them.